Alright, so the graph we're going to do today is f of x is equal to negative 3x cubed minus 2x squared plus 5x. Alright, and so step one of our curve sketching checklist is find the y-intercept or the x-intercept if it's easily found. And so again, the y-intercept is when our x value is equal to 0. Alright, so in this case, this one's actually an easy one. Doesn't always work out this way, because if I plug a 0 in for x, well, y is 0. So in fact, I'm getting the x-intercept and the y-intercept at the same time. Now, we have a polynomial function here, which means there is no denominator. And so, well, the denominator is 1, if you will, but that doesn't really count. And so for steps 2, 3, and 4 is that there are no asymptotes whatsoever. So no HAs, horizontal asymptotes, VAs, or the rare one, OAs, the oblique asymptotes. So we don't have any of those. So again, that's steps 2, 3, and 4. And now we get to step 5, taking the derivative. All right, so I'm going to find f prime of x. All right, so here we go. We did one like this the other day, but we got way more x's involved. So this one's a little bit tougher. And so we're going to have a negative 9 x squared minus 4x plus 5. All right, so now I'm going to set my derivative equal to 0. So let's go here, set f prime of x equal to 0. And what we're going to have to do here is solve a quadratic function. So we got 0 is equal to 9x squared minus 4x plus 5. All right, so again, it is a quadratic equation. I got a 0 on one side, so I'm going to try to solve it using factoring. Hopefully I don't have to use a quadratic formula here. So top term there, I got a minus 9x squared. And in the top right here, I have a 5. All right, well, the only way to get to 5 by multiplying is a 5 and a 1. Or negative 1 and negative 5. We'll see what happens here. Negative 9x squared, I'm going to try negative 3x and 3. And so if I cross multiply here, let's see, I get negative 3x plus, oops, that's an x2, plus 15x. That is 12x. Not even close. The signs aren't going to do anything for me. So what else can we do here? Oh, we could go 9x and minus 1x. Let's see here. Cross multiply, get 9x minus 5x is positive 4x. Well, switch the signs. Now I get minus 9x plus 5x. That gives me the minus 4x. And so that's the right combination there. Sometimes it takes a little bit. All right, so we get 0 is equal to, one of our factors here is minus 9x plus 5. And then the other factor is an x plus 1. All right, so I want to solve each piece, find out when they will be 0. This one's easy. X equals negative 1. It's one of our critical numbers. All right, and then this other critical number, I'm going to have minus 9x plus 5 equals 0. I guess I'll move the negative 9x to the other side. So I have 5 is equal to 9x. Divide both sides by 9. Going to get a decimal, it looks like here. And let's see here. Grab my calculator. 5 divided by 9 is, well, x is equal to 0.55. All right. So there is our two critical numbers, and that's step 5. Now, this derivative is always defined because, it doesn't have a denominator, so we don't have to find any more critical numbers by looking at to see if the denominator is equal to 0. But we do have two critical numbers, and I want to see if they are a max or a min. So, number 6. That's where I draw my number line. And I have, again, two critical numbers, -1 and 0.55. So we have x is equal to -1. And then we've got x is equal to 0.55. And again, our derivative is 0 there, so we don't have to worry about it having a cusp or a vertical tangent. All right, now we have to check out 3 different intervals. I'm going to be looking at when x is less than -1 in my derivative. I also have to look between -1 and that 0.55. And so there we go. So there's our 3 intervals. And so what we're looking at is whether the function is increasing or decreasing. All right, so x is less than -1. Again, I like to use the factored form here to see what my sign would be in those intervals. Just a little bit easier, I find, for me anyways, than subbing into this polynomial. So a number less than -1, I'll pick -2. And so my first bracket, -9 times -2 would be +18. So that first bracket would be positive, but yet the second bracket here would be negative. So positive times the negative. It's negative on that interval, our derivative. Okay, so then the next one here, between -1 and 0.55, I'll pick 0. And if I put a 0 in the first bracket, it's positive. Second bracket's positive. And so on this interval, our derivative is positive, which means, again, our function is increasing. All right, and then after 0.55, well, I'm going to go with 1. So the first bracket would be negative, and the next bracket would be positive. And so again, our function will be decreasing on those. Now we have 2 changes. We go from decreasing to increasing. So that means we have a min at this spot. All right, and then because we're going from increasing to decreasing at x point 0.55 means we have a max at that spot. All right, so what I need to do is substitute those values into my original equation way up here and find out what those values are. All right, so again, I'm subbing in f of -1 into my original function. And so that would be, we would have -3 times -1 squared minus 2x, which is, again, -1, squared. Oh, this one was cubed. All right, plus 5 times -1. Now I'm going to save the gory details. I actually did figure this out already. And the answer was -4. And that's where my minimum is. I also plugged into my original function. Wasn't fun because it's a decimal. It was 0.55. And I got a number of 1.65 was my answer. And again, that's where I have a max. All right, so there's 6 steps done. I know where my function's increasing and decreasing. And I know now where there's a min and a max. And then we get to step 7, where we're now looking at the shape of our graph. Concavity. And so what I need is the double derivative. All right, so I'm going to take the double derivative. Let's see here. I'm going to move this over because I know that I'm going to have to use it for graphing. So number 7. Find the double derivative. Now, I forget what the single derivative was, so I'm going to just peek up here. It was -9x squared minus 4x plus 5. All right, so the derivative is going to be minus 18x minus 4. All right, so there's my double derivative, and now I want to look for points of inflection, possible inflection points. So I'm going to set my double derivative equal to 0. And so this time I just have a minus 18x minus 4 is equal to 0. All right, let's see here. Move that, we're going to get decimal again here. We're going to move that -4 over to the other side, and we get a +4. Changes sides, changes signs. So, and then my lastly here, I'm going to divide by -18. And so I get one possible inflection point here, and my x value is, let me see here, I take 4 and I divide it by -18, I'm going to get minus 0.22. All right, so that's again, a possible inflection point. All right, so let's see here. Where do I want to graph? And I guess we'll go down here. All right, so now I've got to do step 8. Let's see if it's a possible inflection point. And we're also going to find out where our graph is concave down and concave up. So here's my line. All right, I have an x value here of -0.22. All right, so I'm only worried about 2 intervals. For the double derivative, I'm worried when, well, x is less than -0.22 and after it. So x is greater than -0.22. All right, so again, I'm looking at my double derivative here. And let's see here. So I have -18x minus 4. So a number less than -0.22 would be -1. So -18 times a -1 would be a +18. And so on this interval, my double derivative is positive. So that means the slopes is increasing. So the slopes of my tangents were negative. Oh, let's back that up. They're increasing. So the slopes were negative and then turn to positive. So we are concave up on this interval. Now, after -0.22, so a number like 0 works. And if I plug in a 0, it would be negative. And so our slopes are decreasing. So they were started up positive and they're going down. So in this interval here, our function is concave down, which means at x equals -0.22, that is a POI, point of inflection, or IP, I should call it maybe. POI is usually point of intersection. So let's go with IP, inflection point. All right, that's an IP. And so again, that's a special point, so I need to plug that into my function. Now that again wasn't very fun because of that big huge polynomial, but I did it. And I got -1.18 is my, again, inflection point. So, oops. All right. So now our last step is to actually graph this thing. All right, and so I've got an inflection point, I've got a max, I've got a min, and I've got a y-intercept, which is also, again, an x-intercept. All right, so hopefully I don't want to move around too much, so I'm going to try to draw this graph right in here. Now my x values are actually really small. I've got -0.22, I've got -1, I've got 0.55, so this scale is going to be a little bit different here. So I'm going to say, let's see here, I'm going to go with -1 right here. I guess +1 then would be around this area. Again, my inflection point there is -0.22, so I'm going to say that's right in here. All right, and then my max is at 0.55. So, and I've got my min, -1 there and 1. Okay, so there's my graph set up. All right, so my dots, I've got the scale. Oh, I'm going to need, what's our high points here? We're going up to, or going down to -1.118. How high do we go here? 1.65. Okay. So again, I'm going to go with, let's see, let's make this 1 on the y-axis. Let's go with 2 there. And again, we got to do basically the same distance downwards, so that's -1 there. And -2. All right. Just setting up your graph with the proper scale is an art form in itself. All right, so now to graph our function here. So first off, reference points. I got a y-intercept right there at 0, 0. I have a min and a max. I can plug those in. I got, oh man, -4. I didn't see that coming. All right, so I'm going to have to extend my graph. See, setting up your graph. I told you, it's an art form. Missed that one. -3. Oh, man, -4. I'm all down here now. Okay. So, negative, what was that again? -1, -4. All right. Down here. All right. You know what? I'm going to go back. Let's change the Y scale. I want to be able to see my entire graph. So, all right. So here we go. Let's set that back up. So let's, I got to go down to -4. So I guess I can't make these as big. 1, 2, that's 2, 3, and 4. Only we're going down, so got to make my scale appropriate. -2. There we go. So now we can see it. All right. So again, I'm going to plot my min, which is at -1, -4, right there. My max is 0.55, 1.65, so roughly in here. That's my max. All right, I got my min. Oh, my inflection point, which is at x equals -0.22. It goes down to -1.18. So right in my numbers almost. Right in here is my IP, inflection point. All right, so now to graph my function. Using the first derivative, you have to go back and forth. It's not like you can just do use one of these charts and then you're done with it and then go back and use the other one. You have to look at your intervals. So I go left to right, so this function here is going to be increasing all the way, or sorry, decreasing all the way to x equals -1. It's decreasing, and it's also going to be concave up. And number 8 is telling me. So all the way to -1, we're coming down, but we're concave. Whoops, I got a new trick there. All right, here we go. So it's concave up, but decreasing. There we go. So that's that first part. Now, from -1 to our inflection point, well, if it's an inflection point, it is still going to be concave up. And then it goes concave down after that. So our first derivative now tells me from -1 to 0.55, it's increasing. Which makes sense if we look at our dots, it's telling us that already. But it's concave up all the way to this spot. So I'm going to mark that, CU, CU, but then it flips. It goes concave down the rest of the way. Maybe try to draw that just a little bit better. And again, that's why it's always so maybe more subtle. Okay, so again, that's concave down. Concave down in this spot. All right, now after 0.55, well, it's still going to be concave down the rest of the way. My second derivative is telling me. But this is also a max value here. And then after 0.55, my first derivative again is telling me it's decreasing. So it is concave down and yet decreasing. And again, concave down, mark it. And there we go. I put the little CD, CUs in between our points because something could happen there. And I'm also not a very good artist. So every time I sketch these things, I definitely use my pencil very lightly while I'm sketching in the graph, just to make sure I get the shape right and just to make it look pretty.